welcome back to the Leetcode grind. Today we have 2270, number of ways to split array. It says here we're given a zero index integer array nums of some length, and this nums contains a valid split at some index if the following two conditions are true, which is that the sum of the elements on the left side is greater than or equal to the sum of the elements on the right side. And there must be at least one element to consider on the right side. So both sides cannot be empty. Left and right must have at least one. Each partition must have at least one number. And we can start by taking a look at this example here. We have 10, 4, minus 8, 7. And if we look at the explanation, it says there are three ways of splitting nums into two non-empty parts. We can split at index 0, and then the first part is 10, and the sum is 10, and this is the second part whose sum is 3. Because 10 is greater than or equal to 3, this is a valid split. When we split at index 1, then the first part is 14, the second part is minus 1, and once again 14 is greater than or equal to minus 1, and so these two are valid splits. Now once we reach split 2, index 2, this value here, well, the first part is now including the negative 8, which makes the sum 6, and then the second part is 7. Now 6 is not greater than or equal to 7, so at index I, this is not a valid split. And we end here because remember, there needs to be at least one item on the right side, so we don't consider index 3. And our output is 2. Let's try this example here, 2310, and we can draw this over here, 2310. And once again, we have, we have some left partition, and then we have some right partition. And each partition cannot be 0. And each partition cannot be empty, and we can employ the prefix sum. So for the prefix sum, we can initialize left as 0, and the right as the sum of all the elements, because we're going to be going from left to right. So the sum of all elements is 2 plus 3, 5, plus 1 is 6. And now, processing all the numbers from left to right, we say, okay, now this one is part of the left partition. So since right currently contains the sum of all the numbers, let's take it away from the right. This becomes a 4. Let's add it to the left. This becomes 2. And 2 is not greater than or equal to 4. So here we don't have a valid partition. Moving on to 3 at index 1. Now this is going to be part of the left partition. So let's take it away from the right. 4 minus 3 is 1. We carry the 3 over to the left side. This becomes a 5. And you can see it here too. This is the left, this is the right. The sum of this part is 5. Sum of this part is 1. And, well, 5 is greater than or equal to 1. So this checks out. Great. Now let's look at this number. Okay. This, remember, is now our last valid partition because we need at least one element on the right side. And so, well, let's continue. We take the 1 from the right side. This becomes a 0, which makes sense. You can see that here too. And the left side gets added with this 1. So this becomes a 6. And you can see that here as well. And 6 is, in fact, greater than or equal to 0. So this also checks out. Now, had we been able to consider the last number, it would be added 2. But we cannot because we need non-empty partitions. So currently we have 1, 2 that are matching at index 1 and 2. So output is 2, with valid splits at index 1 and 2. Okay, simple enough. Let's now implement. And to implement, let's see, what we did was we had some pre-calculation. So we had a left which started at 0 and the right which started at the sum of all the numbers. And we want to track some result, which is the count or the number of ways to split array. So num ways. Count. Let's say count 0. Okay. And then for each num in nums, but remember we don't want to consider the last number. The last number will remain with right partition. So for each num in nums, we say, let's take it from the right, this number, as we did here. We keep taking it from the right to move it to the left partition, and like so, we add it to the left partition. And at this point, we check, does the left, now if the left is greater than or equal to the sum on the right, then we increment our count. If not, we continue. And let's see, at each point we track the sums, update the sums, and then check if the left is greater than the right. Then we increment the count. Great. And at the end, we can just return count. Give that a go. And submit. And there we have it. Once again, this was 2270, number of ways to split array. Using the strategy of prefix sum, we are able to achieve a linear time, O of n, and space. Space is O of 1 because we just have these constant variables that we use. Thanks so much. Happy coding, and see you next time.